Welcome to the Agentic AI podcast. Imagine an enterprise, right, running thousands of intelligent agents, maybe customer service bots, could be complex internal systems, sifting through just vast amounts of data, handling really nuanced queries.
Yeah, that's the goal for many businesses now.
Exactly. And every single interaction, every response generated, well, it comes with a cost,
Right.
computational cost.
Always.
Now, what if, like, most of those interactions involve repeating similar phrases or maybe building on conversations they just had?
Right, which happens all the time in reality.
It does. And without a really smart system, you're basically paying your AI to reread the same book every single time it processes something.
That's a great analogy, actually. Very inefficient.
Today, we're diving deep into the unsung hero that solves this massive inefficiency, caching. We've got a fascinating stack of sources here, including some insights into a pretty powerful open source tech called LMCache.
Yes, LMCache. Very relevant.
So our mission today, uncover why caching isn't just, a nice-to-have tweak,
No, not at all.
but an absolutely essential piece for truly scaling your AI operations,
Yeah.
keeping those crucial costs in check, and really unlocking the full potential of intelligent agents in your business.
That's the core of it.
So get ready, because you might just rethink how your large language models perform.
Indeed. I mean, the computational demands of today's LLMs, they're truly immense. You could even say exorbitant without careful management.
Exorbitant. Wow.
Yeah, so understanding caching, its fundamental role, it's absolutely critical. It makes these incredibly powerful tools not just practical, but crucially affordable for real-world enterprise use.
Affordable being the key word there.
Definitely. It's really the bridge, you see, connecting that raw power with efficient, usable, scalable intelligence.
Okay, let's unpack this then. We're in this era, right? LLMs like GPT-4, Llama, processing billions, literally billions of parameters, mind-boggling power.
It is.
But you just said computational demands are immense. My first thought is, well, can't we just throw more GPUs at it, more hardware? Or is there something deeper? A fundamental inefficiency, maybe, in the inference phase of that moment, the model's actually generating the response that even raw power can't really fix.
That's an excellent question. And it gets right to the heart of the problem, actually.
Okay.
Because while, yes, more GPUs help you scale up, sure, they don't solve that fundamental inefficiency during inference. The core issue is how LLMs generate responses. They do it token by token, sequentially.
Right, one word or part of a word at a time.
Exactly. And without a robust caching mechanism in place, every single new token generated forces the model to recompute the entire preceding context from scratch.
Wait, the entire thing?
Every time. The entire thing. Think about it like this. Imagine you're writing a really complex email, right?
Right.
And every time you type a new word, you have to mentally go back, reread, and reprocess every single word you've written so far from the very beginning.
Oh, that'll be maddening. You'd never finish.
Precisely. And you can imagine how quickly that leads to, well, skyrocketing latency response times, just slow right down. And predictably, huge expenses because you're paying for all that repeated computation.
Okay, I see it now.
So caching mechanisms, essentially they act like a sophisticated short-term memory, or maybe a really efficient scratch pad.
Gotcha.
They intelligently store those intermediate computations, the thinking the model did for the previous tokens.
So it doesn't have to do it again.
Exactly. It completely sidesteps that need for redundant work, makes the whole process way more streamlined.
You know, that idea of recomputing the entire context, it makes me think of trying to explain something complex to someone who keeps forgetting the first half of what you said.
Right.
You just keep having to start over every few sentences.
Yeah.
It's exhausting. And computationally, it sounds just as bad, if not worse.
It really is comparable in terms of inefficiency.
So it sounds like we're not just talking about, like, small incremental gains here.
Not at all.
We're talking about fundamentally shifting the whole cost-benefit equation for enterprise AI, moving from brute force computation to intelligent optimization. That's a huge strategic advantage.
Yeah, precisely. That's exactly it. When we talk about businesses deploying these sophisticated AI agents to automate tasks, integrate systems, boost efficiency, whether it's, I don't know, a law firm analyzing documents or a hospital interacting with patients or a bank handling queries.
All common use cases.
Right. For them, caching becomes non-negotiable. Absolutely essential. Without it, okay, maybe you have an impressive prototype, runs a few specific tasks nicely.
Sure, the demo looks great.
Exactly. But you'll hit a wall, a hard wall, trying to scale that up to thousands, maybe millions of interactions a day, or trying to handle those long, complex, multi-turn conversations.
Right, the real world.
The real world. But with intelligent caching, you suddenly have a production-ready, enterprise-grade solution, one that can handle real-world loads, complex workflows, without just throwing more and more expensive hardware at it.
It makes it viable.
It truly makes the difference. Proof of concept versus a vital part of your actual operations.
Okay, so if the core problem is basically the LLM's short-term memory needing constant recomputation, how do solutions like LMCache offer something better? A more elegant, maybe even a sort of long-term memory system for these models? Our sources really highlight this open-source KV cache layer. But what is LMCache exactly, and how does it manage to supercharge performance beyond just basic caching?
Right. LMCache introduces a really significant advancement here. Its unique capability. It lies in its ability to not just cache the start of a prompt, which, some basic caching might do.
Yeah, like the first few words.
Kind of. But LMCache intelligently identifies and reuses those key value cache, the KV caches, for any repeated text segments. It doesn't matter where they appear in the interaction.
No, any segment. Not just the beginning.
Exactly, and that's the game changer, because most traditional caching only helps if your current prompt starts identically to a previous one.
Right, which might not happen that often in complex dialogues.
Precisely. But LMCache has this more granular, segment-aware approach. It means that even if a common phrase, or maybe a concept you discussed earlier, or even some boilerplate instruction, reappears much later in a complex chat. Or even in a totally different query that's just conceptually similar, LMCache can leverage the computation it already did for that segment.
Wow. So it effectively remembers and reuses the mental work for specific pieces of text.
You got it. It remembers the work done on those specific segments, dramatically cutting down that redundant processing.
Okay, here's where it gets really interesting for me. That kind of smart, granular caching. It sounds almost too good to be true for enterprise budgets.
Well.
A 50 to 90% saving. That sounds almost miraculous. Are there hidden costs? Or maybe specific situations where those savings aren't quite as dramatic?
That's fair.
And more broadly, how does this intelligent KV caching actually translate into those tangible benefits like reduced latency, better throughput, and those critical cost savings?
It's true. The benefits are pretty striking. And while, it's not magic, it addresses these really fundamental inefficiencies. And that leads to those big savings in very common enterprise workflows.
Okay.
So with LMCache and its advanced KV caching, you see several direct improvements. First, faster inference times.
Right, getting the answer quicker.
Exactly. It dramatically slashes the time to first token, the TTFT. That's how quickly you get the first bit of the response. We're talking 3 to 10 times faster in setups using VLLM, which is a high-performance serving engine. You really notice this in multi-round Q&A, where the model keeps building on context.
Okay, 3 to 10x is significant.
It really is. Second, a major reduction in compute and memory usage.
How does that work?
Well, LMCache can smartly offload some of the cache data, maybe less critical bits to the CPU, or even to disk storage.
Freeing up the expensive GPU?
Precisely. Frees up that valuable GPU to handle more requests simultaneously. That boosts your overall throughput potentially by 3 times. And crucially, memory usage, which can scale quadratically, meaning it grows really fast without optimization.
A big bottleneck.
Huge. Instead, it's optimized using techniques like quantization, basically reducing the precision needed for the data to save space, and offloading, moving less critical cache data to cheaper storage.
Got it.
These techniques mean memory doesn't become this massive bottleneck, even when you're dealing with huge context, like over 1 million tokens.
1 million tokens?
Yeah.
It's massive.
It is. And third, critically for businesses, cost optimization.
The bottom line.
The bottom line, enterprises can genuinely achieve savings anywhere from 50 to 90% on those repeated computations.
50 to 90%.
Yeah. And by integrating with a solid key value store, like Redis, for example, you enable this scalable, low-cost caching infrastructure. It turns what was a heavy expense into a much more efficient operation, hits your cloud bill directly.
The numbers are really compelling. And the explanation of how it gets there, freeing up the GPU, quantization, offloading that makes perfect sense. Now, we've talked a lot about KV caching, but the sources also mention prompt caching. Can you just clarify the distinction? What's the difference between KV caching and prompt caching? And why should we, as AI system architects or decision makers, care about that difference?
Yeah, it's an important distinction to grasp. They both aim for efficiency, absolutely, but they operate at kind of different levels.
Okay.
So put simply, prompt caching is like saving a common sentence or maybe a boilerplate intro you use all the time in your emails.
Right, so you don't type it again.
Exactly. It's about recognizing and reusing the beginning of a request, or maybe an entire prompt if it's completely identical to one seen before. So if lots of users start with, tell me about product X, prompt caching saves the computation for tell me about.
Got it. Caches the input text itself.
Pretty much. KV caching, though, is much more granular. It's more like saving the internal thought process or the intricate web of connections the model made while it was understanding that sentence.
Ah, the internal state.
Precisely. When the model processes words, it generates these keys and values. That's the KV, which represent its semantic understanding, the relationships between tokens. Recalculating these attention computations every single time is incredibly resource intensive.
So KV caching saves that work.
Yes. Think of them as the model's internal notes or maybe its mental map showing how different words relate and contribute to meaning. So next time you build on that thought, or if a specific phrase reappears, even in the middle of a different prompt, the model doesn't have to think through that part from scratch. It just pulls up its existing map.
Okay, that makes the difference much clearer.
Both optimize, definitely. But they do it at different crucial levels of the LLMs. Well, brain activity. And KV caching offers that deeper, more nuanced reuse.
That analogy of saving the internal thought process is incredibly helpful. Okay, so what does this all mean for enterprises then? Specifically, how does a solution like LMCache directly translate into those, frankly, dramatic cost reductions in real-world business settings? Because ultimately, that's what decision makers need to focus on, right? Where does this hit the bottom line?
Oh, the cost savings are very direct, very tangible. Hits the bottom line in significant ways.
I so.
By intelligently reusing those granular KV caches, LMCache just massively minimizes the number of GPU cycles you need. It drastically cuts down the overall inference time for large parts of the processing.
Right. Less GPU time equals less cost.
Exactly. And that leads directly to those 50 to 90% savings on repeated computations we mentioned, which are frankly incredibly common in everyday enterprise workflows.
Like what, for example?
Well, think about retrieval augmented generation RDA. That's huge right now.
Yeah, combining search with generation.
Right. An AI agent queries a knowledge base, pulls relevant info, then uses the LLM to synthesize an answer. If multiple users ask slightly different questions, but they still contain common terms or refer to the same document, LMCache ensures those common segments are processed only once. The expensive generation part only focuses on the novel aspects.
Okay, I see. Huge savings there.
Or consider an insurance company processing thousands of claim inquiries daily. Or a legal firm sifting through case law. Many queries share common legal terms, factual context.
Lots of repetition, even with variation.
Exactly. Each one of those repeated, slightly varied queries that can leverage a cached KV state represents a direct, measurable saving in compute resources.
So it directly optimizes IT ops.
Absolutely, and genuinely accelerates digital transformation. It makes deploying robust, private AI agents not just technically possible, but actually cost-effective at scale.
Right, which is crucial for widespread adoption. Now, while the benefits are super clear and honestly really exciting for anyone looking at AI at scale, it's rarely a completely smooth road, is it? Implementing new tech. What are some common challenges, maybe some gotchas, that enterprises might run into when they look to implement and manage LLM caching solutions like LMCache?
You're absolutely right. There are definitely practical hurdles, things you need to plan for.
Like what?
Well, one of the primary concerns is just storage overhead, especially when you're dealing with those really large contexts we talked about, maybe 1 million tokens or more.
Right. Caching all that data takes space.
It does. And it's not just the disk space, it's also the latency of retrieving that cached data quickly enough, especially for real-time applications. If your cache gets too big or too slow to access,
the benefit disappears.
Exactly. The efficiency gains can just evaporate. You could even turn your supposed advantage into a new bottleneck.
Okay, that's a big one. What else?
Another significant challenge is invalidation, particularly in dynamic scenarios.
Meaning when the underlying information changes.
Precisely. If your knowledge base updates, or maybe the context subtly shifts, you need smart ways to make sure outdated cached data isn't used.
Yeah, that could be bad. Giving wrong answers from old data.
Very bad. Imagine your product specs change, but the AI agent is still pulling answers from an old cache description. It gets really complex in real-time systems where info is constantly evolving.
So keeping the cache fresh without losing the benefits.
It's a delicate balance, needs intelligent mechanisms.
Okay. Any other major hurdles?
Well, finally, there's maintaining consistency across distributed systems that presents its own difficulties.
When you have multiple copies of the model running.
Exactly. Maybe multiple servers, instances, possibly even across different data centers. Ensuring they all have access to the right cache data and that it's synchronized correctly, that's crucial for reliable performance.
Otherwise, you get inconsistent results.
Right. Without robust synchronization, one agent might get a fast cached response, while another, for the exact same query, recomputes everything, leads to weird user experiences and, again, wasted resources.
Absolutely. Those are definitely real-world considerations. Need thoughtful architecture. Yeah. Now, let's connect this back to the bigger picture.
Okay.
How does robust intelligent caching specifically underpin this grand vision of powerful, truly scalable agentic AI for enterprises? What kind of future does this efficiency really unlock?
Well, I'd say it underpins it entirely. It's foundational.
Foundational.
For enterprises to move beyond just prototypes, you know, to truly automate complex tasks with intelligent agents. Agents that can integrate seamlessly with existing systems, deliver unprecedented efficiency and speed, while also ensuring those critical things like data privacy and control. Efficient caching isn't optional. It's not an extra. It is the foundational layer.
Okay, so what makes it practical?
It's what makes the promise of effortless AI or solutions optimized for your enterprise a tangible reality, not just marketing speak. This efficiency allows businesses to innovate much faster, deploy advanced AI agents across way more functions, customer support, internal R&D, complex workflows.
Without breaking the bank.
Exactly. Without running into those prohibitive compute costs or performance bottlenecks, it's really the engine that enables that future where AI agents are not just powerful, but also practical and pervasive across the business.
What a deep dive. Seriously. We've seen how caching, especially sophisticated solutions like LMCache, really transforms LLM performance. It takes it from what could be a massive computational drain into a lean, mean inference machine. It really feels like a shortcut, a necessary one, to unlocking enterprise AI's full potential, making agentic AI practical, not just aspirational.
Absolutely. And I think it's important to stress this isn't just about speed, faster response times or more throughput, although those are great.
Right.
It's more profoundly about enabling a future where these AI agents can operate at a scale we haven't seen before, stay cost-effective, and critically maintain complete data control.
Which is huge for enterprises.
Huge. It empowers businesses not just to automate the mundane, but to innovate rapidly, tackle really complex workflows with confidence, all while keeping those operational expenses manageable.
Okay, so for a final provocative thought for you, our listener, to chew on, just consider how many repeated queries or similar tasks or even just slightly varied prompts does your organization perform every single day across all its different functions, internal analytics, customer interactions, everything.
It's probably a staggering number if you actually count it.
I bet it is. Now imagine the cumulative savings, the speed gains, if every single one of those could intelligently leverage advanced caching, like LMCache, learning from past interactions, reusing that computational effort.
Yeah.
What entirely new frontiers, what previously maybe unimaginable AI initiatives would that kind of pervasive, intelligent efficiency unlock for your business, for your digital transformation journey?
Something to really think about.
Definitely something to think about. Thanks for joining us on the Agentic AI podcast. We hope this is giving you a fresh perspective on how to get the absolute most out of your AI investments.